All right, so yes, so let's look at this in another way, so to speak. Now, the first 8 pages in your data file, or in, yeah, basically, let's look at it like that. In your data file are actually reserved for these bitmaps. First page is a header page that identifies, okay, this extent, this group of pages, this is what it's about. The next one is the page free space. A PFS actually means page free space. It basically tracks which of your pages are free. This is typically related to the temp DB. And then the GAM, the global allocation map, the SGAM that I've mentioned. Fourth page is unused, and then you have the differential change maps and the bulk log change maps. All right, so let's look a little bit at this physically speaking. All right. So now we talked about logical structures and physical structures. I have a small database here, and if I were to look at its properties, now these are the properties of the database. The files that my database is sitting on are located on my drive C and E, log and data. So if I go to my drive C and E specifically and go to C/MSSQL data, I can see my AU file. This is my master data, my main data file, MDF. The properties of this file tell me that this is an MDF, and it is, if you write any file, how do I put it? If you change the file extension for any file on your OS to MDF, it will look as if it can be read by SQL Server. But of course, it won't. If it's not the real MDF, it will be read by SQL Server. But the point is that is a file extension that data files use in SQL Server. And here you see the details of the file, the nature, the details of that flat file. So as far as the operating system is concerned, this is a file, basically. This is the file that the master database will open when it says it needs to open your databases. Every table that you created in this database is stored inside this file on pages. Those pages are aggregated into units of 8 pages called extents, and so on and so forth. And those extents, those pages, those groups are tracked by what you call allocation units. The allocation unit allocation map pages, basically. The GAMs, the SGAM, the IAM, and so on and so forth. So on the other hand, you have the log files too, which are sitting on another storage, on another drive called my AU_log. You see the properties of this file. It's also an LDF, and I can create a third database file type called an MDF, a secondary data file. I'll show it to you shortly. So that's where they sit on the OS, and SQL Server exposes to us some of the details of these files, whether the size, the auto group settings, and the names. Now, if I decide to add another file here, I can call it whatever I want to call it. I can call it, let's say I call it AU_02. Now, when you're doing this kind of thing, I like to keep my naming consistent to be able to track my pages. Rows data, there's 64. Now now let me do this. You see that there's no file name here, and I'm going to put let me remove this. I'm going to put the data file in my MSSQL/data path, automatically SQL Server will append the .ndf file extension on this new file that I'm going to create. So you need to be aware of that. Where is it? Let's go back to the operating system and see what has happened. Data. Sorry. All right, so A02, this is a SQL Server secondary database file. The first one was the SQL Server primary database file, and we see the properties that the extension is an NDF. All right. Okay. Let's go back to our slide. Now, what else are we seeing here? Now, we mentioned the concept, these are files, right? And we mentioned the concept of file groups. So logically speaking, my files are grouped into is what we call file groups. Is a way of, now, if I want my table to sit on a specific file, I cannot do that from inside SQL Server, but I can create a file group that contains the files where I want it to sit, and then determine that that table will sit on that file group AU03, and I'll change the file group, create a new file group and call it FG02, and okay, and then whatever I call it, and I say okay. So basically what I've done, let's go back to the properties, is that I now have two file groups. The primary, every time you create a new database, it comes by default with the primary file group. You can create other file groups if you want, and here we see the file groups page that tells me how many files I have in each file group. And when you say your file group is the primary is the default, that means if you create a table without specifying the file group, then what happens is that that table sits on the primary file group. Before we go ahead on this, we'll come back and see one or two tables here, and we'll see the row overflow data table, and let's see the properties of this table. We see that the name and all that. Then the storage, if we go to the storage of this table, we see that the file group where it is sitting is primary. That means this logical structure called the table is sitting on a physical structure called a file, is sitting on a particular extent, on a particular set of pages, and that set of pages is on a flat file on my operating system. The only way I can know from a high level, whether my data file, whether my table is sitting in terms of data file, is by checking the files that are in the primary file group. So you see that these file groups try to abstract the OS so that you don't have to, from inside the database, be managing data files, logical, the mapping between logical structures and data files directly. So this file group gives you ability to do that. For example, I can create another table. Let's say this is use AU, go, create table, FG, let's just call it FG, whatever, ID, and let's just do one column, file group. Right? In fact, I think it's on. So, am I correct? Yes. Invalid file. What's the name of the file group I used again? FG02, right? All right. So basically what I've done, I've created another table. Of course, you know, I may have mentioned that there are many other things you can specify about the table. You can specify which files it is on. We'll go into that. We'll go into that more. But here I specified which file group this table should sit on. And when we go into the details of this table, dbo.fg, we see that it is sitting, the table name of table is fg, and when we look at the storage details, it's sitting on the file group .fg2 because I explicitly specified that file group in the creation of the table. Now, why would you want to do this in production? Let's assume that you have a table that is supposed to be storing transactional data, and you have another one that is supposed to be storing historical data. You can store, because you want the contention, maybe you want one file that has the transactional data tables to be on very fast storage, let's say on flash. You can put those files there, and then the other files that you want to be for historical data, you can put them on cheaper storage, let's say on a maybe 15K or 10K disks on a different set of storage, right? You do that separation. The only way you can do that separation of where your data files are sitting is by using file groups, by grouping your data files logically. And this is what basically we've done here. I think that is clear. There are many other reasons for example, in a technology like partitioning. In partitioning, we basically would also use different file groups to store different partitions of the table. And one of the key reasons why you do partitioning is to be able to switch out, basically manage historical data in SQL. If we have time, we may do an example of that. So these are logical structures. What else do I need to show you? Yes. All right. So we looked at the files and the file groups in brief. We need to do a little bit of a command and see whether we can see into this table. I think it's dbcc database console commands page. Let me see. Okay, yeah, so let's use this. The page, we will use it to investigate two pages. There are two tables that we just created. New query. So there are what you call, this DVCs actually means database console commands, and I think it was partly developed by a man called Paul Randall, who used to be at Microsoft. So if you want to know DBC very well, he's the guy you should be looking for, Paul Randall. But let's look at these options. I will not go into the details of what these options mean, but these are used to basically investigate the internal structures of logical objects. Okay. One minute, please. Select from sys.objects. I'm sure some of us already remember when name equals to overflow. We remember some of our system catalog views, and these are some of the uses of these catalog views. object ID. Give me a minute, please. Let me get the syntax right. So any questions so far? These are the beginnings of the beginnings.
Yeah, let me quickly ask my question because I'll be leaving in the next 1 minute, please.
Tell me.
Please, why was those saved in two different drives?
Okay. So basically, it's a historical thing in SQL. Now, some people are arguing about it these days because these days most of us are using storage SAN, that is storage area networks. Now, historically, if you are using physical spindles on your storage, the way that SQL reads a data file is different from the way it reads and writes a log file. SQL Server reads a data file in a random fashion, random access. Read, write here and there. But in a log file, is appending. So it's writing sequentially. So in order to improve performance, it is advised that you put your data files on a different storage spindle than your log files. So it was very, very important for performance, especially when you are using physical disks on your server. But these days, the importance is reduced because now we're using storage area network. So in my practice, you should always separate your data files from your log files. Now that's one area. Now the other area is where we talked about the primary database and the secondary data file, depending on what you want to use it for. For example, I mentioned the case of if you are storing a transactional table and you want the response to be very quick. So you want to store it on a high-end flash storage. And you also don't want to waste your flash storage storing what doesn't need to be there. So you can create two file groups, one that sits on the flash storage, another that sits on the normal 15K of 10K disks that is for historical tables. So that is how you separate you are able to optimize your environment by using your storage very well. So file groups allow you to make those abstractions, those separations. You get the picture. All right.
Yeah. Thanks.
You're welcome.
So how will be available on YouTube, right?
Yes, please. The continuation will be.
Okay. All right. Thank you.
All right. Thank you so much. So another time.
Yeah.
All right. So Prince, yes. I don't know whether Eben is here right now. Oh, Theophilus is here. Theo, how are you? I greet. All right. So where were we? All right. Let's use this. Let me use this to determine we want to look a little bit inside. Yes, we're here. Yes, hello Theo. How are you?
Yeah, this
Prince.
I have a question there.
Tell me.
Okay, so if I understand,
Yes.
the reason for using the secondary file group
Yes.
for purposely for like the archiving data.
Yeah, you can use it for archive
primary
data.
for the transactional.
Exactly. So basically, the fundamental idea is that you want to separate your tables on different sections of storage. There are many reasons you want to be doing that, but one of those reasons is you want historical data because you're not going to be accessing it too much. You want it to be sitting on some older or slower storage, right? Okay, let's give an example of core banking. Let's say in a core banking environment, you have a table called ACTB daily log. The table, the transactions on it, they are very rapid, very swift, so you need fast storage. Then you have another table called ACTB history. That one, people only touch it once in a while, and most of the activity there is read activity, right? Now, you have your storage in 3 tiers. Tier 1, maybe 4 tiers. Tier 1 is flash storage. Tier 2 is 15K. Then you have 10K. You have 7K. Now, the operating system guys have given you 3 LANs. They have given you the flash LAN. They have said, oh, this LAN is too expensive. We can only give you 100 gig. Then they give you the 15K LAN. They will say, we can give you 200 gig on this. And then they'll give you the 10K LAN, which is maybe 500 gig. They're giving you that based on the fact that they are trying to save costs, and they've really fast storage. They have reserved it for special cases. And you want your transactions to be very fast. So you want your tables that are handling your transactions to be on flash storage. The only way you can determine where a table is sitting at the storage layer is to put it on a file group that has been created on that storage. So the file group is the abstraction layer that you determine where your files are sitting. You get my point?
Okay. Yeah, I get it.
You get it now, right? Okay, cool. So those are the use cases. And another key use case is partitions. When you're doing partitions. Okay. Sorry, I'm trying to get, there's a syntax I want to get. Okay. Sorry about that. No, that's not what I'm looking for. Okay, we are going to do, let me see whether we let's get another workaround. Forget this.
Okay, I second question.
Yes.
Okay, so recently, we had Setri and I, we had a work we had to work on
Okay.
with file group.
Okay.
We actually had an alert which was showing that the file group was, I think, was full, so it was showing alert.
Yes.
But then per our investigation, so the alert didn't advise us on the recommendation, the way to do that. We can delete unused data, or we can recreate, like add an additional file group.
Okay.
Or we can is it delete unused data?
Yeah.
I don't know. Okay, you go to, I'll get the exact error.
Yeah.
And
Okay.
we will take it and then we.
So what was the difficulty?
I'm checking.
What was the difficulty?
So what we did was that we had to add a new file group, the secondary file group.
Okay.
The secondary, that is just the end. but then it was set to unlimited. You see, we have some parameters.
Yeah.
So we set to it. By initially it was unlimited already, but then since we are adding a new one, we had to limit the previous one, and then we had to leave the old one to unlimited and then the new one to unlimited. I was confused there.
Okay.
This like very good. Okay, I can see the screen. So you see the auto growth.
Yes.
Initially the primary, it was limited to I think 200 gig.
Okay.
And then it had a secondary file group, which was .nef. That one it was unlimited. So but then the alert was still insisting us we should create another file group, like we should add another file group. So we did that, and then we had to leave the previous one unlimited and then the new one to unlimited.
Okay.
But then after we did that, we didn't see the error again.
Okay.
We see the error, it was coming up again. But I don't know why do we have to limit it, or why is that it should be unlimited, but then it still be throwing an error?
No,
you have to either add a new file group or
it would have been nice to see the exact use case, but it cannot if it's yeah. If it's once you
I'm opening my mail, I'll get the exact error, then use it to
as a case.
work around or study.
Yeah, that's fine. But you see, once you have either allowed a large amount of space on that file group or you've set it to unlimited, then it will grow. But you see, I typically would even limit mine to a particular size and manage it properly. I would limit it. Like I said, I like my files to be like 100 gig, right? And that's why I remember, I don't know whether I've mentioned to you pre-allocation, where you, at the beginning of creating a database, you determine how big that database is likely to be. Well, depending. Sometimes the database is so big that you don't want to keep that. It's going to be so grow so much that you don't want to keep all that amount of storage lying idle. But typically, you would want to, determine for most of your databases what is the maximum size it could get to, so that you give it that size at the beginning and your management is better. And you also want to limit, because you want to be sure that your data files don't grow too large, because when they grow too large, they become difficult to manage. You have problems with all those allocation unit contention issues and so on and so forth. But let's see the error you have while I'm looking for what I'm looking for here.
Sure, I'm looking for the error.
Uh,
Okay, please, I've seen the error. Can I read it out?
yeah, or you can just drop it in the chat. Let's see.
Okay, so it says could not allocate space for object db.r_result setting dot result r_output setting pks in database focus db, because the primary file group is full. Create takes place by deleting unneeded files, dropping objects in the file group, adding additional files to the file group, or setting auto boot for the existing files in the file group.
Yeah, so
So this was the error.
those are the four things you could have done. But so which one did you say didn't work?
Okay, so per the recommendation, we actually have to
You
add
added
a new
space
file
on
group,
it.
an additional file group
Okay.
to it.
Okay. So
But then
what
when
was
we
the
checked the parameters on the file group, it wasn't full. Like it was set to unlimited. So we shouldn't expect that error from that particular database.
You're saying the primary file group wasn't full.
Yeah, no, it was set to unlimited,
Okay.
like what we have here.
What about there was the operating system level disk full?
No, it wasn't full either.
Uh, so you're saying that it was set to unlimited, right? Like this,
Yeah,
and auto growth was
yeah.
enabled. Auto growth was enabled.
Was enabled on the yeah,
What?
yeah.
You're not sure whether auto growth was enabled. Okay. It was enabled.
Yeah, yes, it was enabled. Okay, I will log into the database, get the file group
And
separately,
settings and
check
see.
what we have there, and then I'll also read it out to you. So you proceed with what you are doing.
Okay,
I'll
that's
get
fine.
that one.
Remember the maxim: machines don't lie.
Sure.
Okay. All right. Now the script I'm looking for, I'm not getting it, but I'm sure I'll get it at a later time. So we'll proceed with other aspects. What I wanted to show you is how you can actually see the details of these files, of these tables, and where they are sitting on. But I'm sure we'll come back to it later. Okay. So let's proceed with other aspects. So
Okay.
did I? There should be a part of this where I'll talk about in-row data files, but I'm sure I'll come to it. So let's do something practical. Let's do some nice practical stuff. Moving database files. And we have said that your tables and indexes and all that, they are logical structures. They are sitting on a physical structure called a file, and that physical structure is broken down to pages, extents, and so on and so forth. Now, if I want to move my database, if I want to back up my database, what I'm doing is basically making a copy of the file and writing it to somewhere else. That is why when you take a backup of a database that doesn't have free space, the size of the database backup is the same as the size of the database, except you have done compression. So it's basically a copying a database to another location. So if I want to move my database, I'm going to have to move my files, and there are techniques for doing that. There are techniques for moving system databases, if you remember system databases, and there are also techniques for moving user databases, and some of them are related techniques. So we'll do just if one or two of those movements, and then we will see how it works. The procedure is typically just 4 steps. I'll do it in 2 different ways, and then we will see how they work. All right, so let's see. I believe I have one of this for temp here. This is the procedure for temp. The first thing, I want to know where my files are in the first place. And in knowing where my files are, my data files are for temp, I want to query the catalog view sys.master files. So that can tell me where the files for any database are. In this case, I have isolated the database I want to move to TempDB. Because the sys.master files catalog view does not have my database name, I am converting the database name to a database ID with this dbid function in order to pass it in my filter. So this is where my files for my TempDB are. Now the question you want to ask yourself, why would you want to move your data files? There are cases, for example, where your storage is getting maxed out and you can't add any more space. So you want to move to a new storage entirely. There are also cases where you want to move your database to faster storage, like I mentioned the other time, from let's say your 15K to some flash. There are also cases where you just want to organize your database better. I remember the case we had with one very large database in a cardholder environment, where once in a while because it's a VM, the database cannot, the storage allocations cannot exceed 2 terabytes. So the operating system people have to add another LON for you. They have to add another drive entirely. So you now have to do an operation that moves the data file from its existing location to that new LON, because you can no longer extend that storage. So you have cases like that to be able to do that. Okay. So let's do this for temp. Let's say I want to move my primary TempDB data file. I want to move it to my drive E, right? All I have to do is to do these commands. I'll do it for only one of the data files. Now my logical file name is tempdev, so you need to also know this when we created. There's a logical file name associated with the files of this database. There's the physical file name, which is what you see on the operating system level. You can notice that they can be different, but ideally you should have them the same so you don't create confusion for yourself, ideally. Now I'm going to ask data. Now in the syntax of this statement, the name you are referring to here is the logical file name, right? And then the file name you're referring to is the physical file name. So we want to say move this file, which we are identifying by its logical file name, move it to a new physical location. So we're going to see where we're going to move it to. It was originally in drive C, right? This is it. Where is it? Let's see. Oh, sorry about that. C MS SQL data. Where was it? It's in, okay, it's in a path here. Let's see. Let's just get that out. So it is in the, this is another interesting reason why you want to do this movement. You know, when you originally install SQL Server, sorry about that. When you originally install SQL Server, by default, all your system files go to the installation directory. So there are times when your temp requires much more space than you have available in drive C. So basically you want to move it to a location where you have more space. So we're going to move TempDB from here, and we're going to move it to another location. Let's say drive E, data store E. Let's just call this temp. Okay. All right. Okay. Yeah. So we're just going to do that. So once we do that, it says the file TempDB has been modified in the system catalog. So this is a command that simply tells master. You remember that master is the guy who opens all the databases. and the first database it will open is the temp, if you remember from the last lecture. He's telling the master database that, look, guy, this file, this logical file which you have in your records is located in this physical path. That's what he has told him. Now, if you try to restart the database again, you will see what will happen in the case of TempDB. We also see what will happen in other cases. So let's try it out and see. I hope I don't SQL Server Configuration Manager. Okay, I think I'll have to start my recording again so that what happened to me last time won't happen to me again. So